Wind in Unreal is surprisingly simple or complex depending on your approach. But in this video I want to go over how to set up a simple and easy to understand system that simulates wind for your entire level. Now, since fortunately for us, Quixel Megascans has already done most of the heavy work regarding foliage, we won't spend too much time on it. But if you haven't already, seriously check out the free tree packs that they provide for free to all Unreal Engine users. Although what interests us the most right now is not the trees themselves, but the Megascans preset folder that it comes with. Here is where you'll find the main blueprint for controlling wind in the global foliage actor. Now if you open it up, you can check out all the logic that decides our parameters for wind, season, and color variation all neatly lined up. And then if you go into the master foliage material, you can dissect our wind logic and see how the material moves the trees. But again, this is a done and solved issue, so we'll move on to some of the more interesting stuff. So to start off, we'll do some fun physics stuff and have wind push around objects in the scene. I'm going to create a folder here, call it Wind Blueprints. Alright, so let's create a new blueprint. Call it Wind Zone BP. Add a box collider to it. And call it Wind Zone Area. We'll make it so that any physics-enabled objects that are in this area will be pushed around by the wind. Alright, the first thing we'll do is get the wind zone area, and then get overlapping components. Drag out from the overlapping components and get a for each loop. From here, use a branch to check for is simulating physics. And then add force at location. Then drag out from the array element and plug this into the target pin. Sorry, got the wrong force. Alright, now drag out from the array element again, and this time get world location. And drag out from the branch to insert a get actor from class. And then select the global foliage actor. And then drag out to get the world rotation. Important note here that we are not going to use wind direction for our blueprint here, because add force at location requires a vector, whereas the wind direction used or created by the global foliage actor only gives a number between 0 and 1, and what we need is x, y, and z. So what we're going to get here is get forward vector. Alright, what we're gonna add next is a total of 3 multiply nodes. Alright, and what we're gonna drag out next is get the wind strength. We're gonna plug that into the first multiply node. And with that, we're gonna combine with a random float in range. Choose a number between 0.8 and 1.4-ish. This will give our wind a little bit of randomness. Alright, and this one I'm going to turn back into a float. And we're gonna set this to 80k. And from there we put our final result into the force. Compile and save. Oh, and one last thing, we need to set the box extents. We're going to need to create 3 new variables, zone X. Change that to a float. Duplicate it, create zone Y, then duplicate again and zone Z. Plug those into our pins. Compile and save. With that, we can now set our new box values. Let's set them down to 200. Alright, now drag in the blueprint and start adjusting the size. Oh, minor mistake, we need to make these visible first. Alright, expand the size of the box. Have it encompass the whole little bit of area here. And before we can actually see anything, we need to create a few physics objects. Call it wind cube. We'll keep it simple. Just drop in a cube and enable physics. Alright, drag them in. Duplicate a few times. And now press play. And now you'll see them start to move. Not quite the direction I want to see though. I'll change the wind direction over towards us instead of away. And there they go. Now the wind force is a bit strong. I don't want them being sent completely off into the abyss immediately. So I'm going to lower that down a little bit. And now we're going to move back into the global full ejector. Now we're going to make things a little more dynamic. Now, preferably, you'd want to create a more elegant timer using world delta time, but since it doesn't matter at this stage, we'll take a bit of a shortcut. Create a sequence node. Put pin 0 into the run global full ejector. And then from here, we'll get the wind strength. For our new wind strength, we'll select a random float and range. Let's duplicate the wind strength variable. Set those up to be our wind strength min and our wind strength max. Drag those in. And now we have a way to control our variance in wind. And since we don't want this to happen on every take, we'll put in a delay. And we'll promote to a variable and call this weather change rate. Alright, with that, we can compile it, save, and then change the default setting to about 3 seconds for our change rate. Well, at the moment, our wind strength is a little too much, so our cubes are getting blown off before the wind has a chance to change, so let's decrease that a little. Alright, push it down a little bit more, and let's give it a playtest. Alright, as you can see, the wind is changing over time, and we see the cubes coming to a stop before the wind starts picking back up again. Alright, I'm going to lower the wind a little bit more, but that's enough for that. We're going to move on to cloth next. Alright, what I got here is a very simple plane. Nothing special about it except having some additional subdivisions for a little bit of a more accurate simulation. Import it in and enable skeleton. Alright, open up the skeletal mesh. Right click, create clothing from section. Click create and then activate cloth paint. Alright, from here we'll start painting white all the areas we want simulated. We'll turn this into a soda flag. Alright, deactivate cloth paint and right click, apply clothing data. There is a bit of a bug that I believe is exclusive to 5.3 where our paint values are not applying correctly. Head over to the paint values and set that to 1000.
And now, as you can see, it is simulating as it should. I do believe this bug is exclusive to 5.3, so any other versions of Unreal should be fine.
Alright, now let's drag in our little flag. Alright, now let's place our wind directional source, and our flag will start flickering a bit, but I think that's just a minor glitch. It'll work just fine. Now if you press play, it won't do much yet because we haven't set things up, so let's get on that. Increase the strength value to 50 and up the speed. Alright, now it's finally looking like it's blowing in the wind, but it's not going in the right direction. That's because the wind directional source is, at the moment, independent from the global foliage actor. So what we're going to do next is work those two together so that we can have one control everything. Now I really wish we could just drop in a wind directional source into our blueprint directly, but since we can't, we're going to have to call it from the blueprint graph. First, get actor of class, get our wind directional source, and from there we're going to set actor rotation. Set world rotation. And we're going to set its new rotation to be the same as our icon root. Now compile and save, and you'll see that our flag is now moving in the correct direction. Alright, I'm going to push up the force on our cubes a little bit back up. Alright, next thing we do is that we need to transfer over the strength values from our global foliage actor over into the wind directional source. Now you'll notice that the wind strength value in our wind directional source is a lot larger than the wind strength in our global foliage actor, so we're gonna need to multiply that up a bit. Alright, I'm gonna multiply that up by 25. But before that, we'll do a print strings. That way we can visually see the exact strength of our wind that we're getting. I moved that one a little bit too much to the side. I'll bring that back in. Alright, now press play. And now up in the corner, every 3 seconds, you can see our wind direction changing. Alright, that's really nice. We got our foliage moving, we got our wind flag moving, and we got our physics cubes getting pushed around. Alright, let's add one more thing. Let's change the wind speed of our cloth wind simulating actor. Oh, hold on, I think I got the wrong speed. Alright, and again, the wind speed values are going to be a lot larger on our wind directional source than our foliage global actor, so we're going to multiply that up a bit as well. And I guess we can also change up the speed over time as well. Alright, copy over a random floating range. I don't think I'll be creating variables for this window. Alright, reconnect the print string and let's continue on. Because, as you may have noticed, our wind is affecting our foliage, our physics objects, and our cloth, but not our character, so we'll work on that next. Alright, open up third person character. And drag out the movement input. Alright, drag out and create get actor of class and get the global foliage actor. Alright, from here again, we'll get the world rotation and forward vector. And this will connect to a dot product. And for the second input on this, we'll get the actor forward vector. That'll be the direction our character player is facing. Alright, and from here we'll do an addition of 1.5. And then a division of also 1.5. And this is what will be multiplied with our movement input. Alright, and now if we start moving, you'll see that we'll move slower when facing against the wind. And then as soon as we stop moving against the wind, you'll see our character speed back up. Alright, let's go back into the blueprint and add a print string. We'll use this to better observe our speed changes. And now if you press play, you can visually see how the wind is affecting our movement values.
And now with our wind effect taking place, you only get a value of around 0.34 when moving against the wind. You also get excessive values when moving with the wind, but we'll get rid of that with a clamp.
With this, we can set our clamp float to -1 on the min and max1 on the max.
And now we have a little more control over the values that we get.
And of course, that's not all we can do. At the moment, we are only affecting the movement input of our character. We can go further and change values in our character movement components, such as for our sprints and the way our crouch is affected by the wind. And even further than that, we can add animations for our character as they push against the wind. But this video was intended as more of an overview and the way that you can implement wind. So that is all for now.